April 17th, 1967. NASA launched Surveyor 3, the unmanned lunar lander. The primary purpose of Surveyor 3 was to perform a soft landing on the Moon and provide detailed information about the lunar surface, which was essential for the planning of the Apollo missions. The spacecraft carried scientific instruments, including a television camera for capturing images of the lunar terrain and a surface soil mechanics experiment to test the physical properties of the Moon's surface. Apollo 12, the second manned mission to the Moon, has a unique and exciting plan regarding Surveyor 3. During their mission, the Apollo 12 astronauts aim to land their lunar module, Intrepid, near the Surveyor 3 spacecraft. One of their primary objectives is to visit Surveyor 3 to conduct a detailed examination of the spacecraft and its landing site. The astronauts will collect parts of Surveyor 3, including its television camera and other components. These pieces will be brought back to Earth for thorough analysis. By studying these components, scientists hope to gain valuable insights into the durability and longevity of spacecraft materials, which is crucial for the planning of future long-duration missions. This ambitious plan will mark the first time humans visit and interact with a spacecraft that has previously landed on another celestial body.
T-minus 40 seconds and counting. The spacecraft commander now performing his final function, pressing a button to align the guidance and control system of the spacecraft. Coming up on 30. Mark, T-minus 30 seconds and counting, T-minus 30. 25 seconds and counting, we're still proceeding. T-minus 20. 17 seconds, swing arm back. We have guidance internal. 10, 9, 8, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engines running, commit, liftoff. We have liftoff, 11:22 a.m. Eastern Standard Time. Pete Conrad reports the yaw program is in. Tower clear. We got a pitch and roll program in this thing here, really going.
Pete Conrad reporting the roll and pitch program to put Apollo 12 on the proper course. Altitude at 1/2 mile.
Roll complete.
Roger, Pete.
Okay, we just lost the platform, gang. I don't know what happened here. We had everything in the world drop out.
Roger. +1.
3 fuel cell lights and AC bus light. Fuel cell disconnect. AC bus overload 1 and 2. Main bus A and B out.
How's it looking, Ecom? Ecom, what do you see?
Flight Ecom, try SCE to off.
Say again, SCE to off.
Off.
SCE to aux.
Auxiliary flight.
SCE to aux, Capcom. What panel?
Apollo 12 Houston, try SCE to auxiliary, over.
NCE auxiliary.
SCE to auxiliary.
What panel, Ecom?
We got it back, flight. Looks good.
Okay.
Ecom reports the readings
Okay,
back.
Go down by 1 Charlie.
Roger.
Mark 1
Mark
Charlie.
1 Charlie.
Staging status.
1
Boosters,
Charlie.
Flight Director Jerry Griffin taking a staging status now. Apollo 12 down range 17 miles. Altitude 20 miles.
Try to put the fuel cells back on the line. It's not side back Charlie to main A and B.
Okay, try to reset him.
Apollo 12 Houston, try to reset your fuel cells now.
No buck side back Charlie to main A and B.
Head inboard out flight, we're looking good.
Inboard engine out on
On the
schedule.
line, meet fuel cell 3.
Okay, he's working. Staging flight. There's the
Got a good S2, gang.
Roger, we copy, Pete. You're looking good.
Good staging and good thrust on the second stage.
Straighten out our problems here. I don't know what happened. I'm not sure we can get hit by lightning.
Thrusters go, flight. Roger.
Your thrust is looking good, Pete.
Okay, I have a good GDC, and Al has got the fuel cells back on, and we'll be working on our AC buses.
Right, Pete. Your fuel cells look good down here.
The lightning strikes caused significant electrical disruptions, resulting in the command module losing power and multiple warning lights illuminating. Key systems affected included the inertial measurement unit, IMU, critical for navigation, and the signal conditioning equipment, SCE, which converts sensor data to a readable format. Despite the electrical issues within the command module, the Saturn V rocket continued its ascent unaffected. The Saturn V's independent power supply, including onboard batteries and separate power buses, ensured the rocket engines functioned normally. This redundancy allowed the rocket to maintain its course and power through to orbit, despite the temporary loss of telemetry data and guidance in the spacecraft.
We had 11 electrical warning lights associated with the electrical panel, and in all our simulations and double failures and triple failures, they never figured out how to light all 11 of them one time, but they were all on.
Later on, Al asked me why didn't I help him. I
Yeah.
did help.
He wasn't quite as polite as he's saying it right now.
I said, I didn't help Al because I didn't know what the hell to do.
We learned a lot that day on Apollo 12.
We became the longest lightning rod in history.
Okay, we're all organized again, Jay.
We've had a couple of cardiac arrests down here too, Pete.
And I'll tell you one thing, it's a first-class ride, Houston.
You gotta go orbit, you're looking good.
In space and on Earth, they checked out the systems to be sure that the lightning had caused no damage that would endanger the mission. The time for commitment neared. The burn to send Apollo 12 to the moon. Translunar injection, TLI.
Apollo 12 Houston, the good word is your go for TLI.
Whoopie-doo, we're ready. We didn't expect anything else.
We didn't train for anything else, Pete.
You better believe it.
We have data and thrust is go. Burn looks good.
With engine cut off, Apollo 12 was on its way to the moon. Now they turned around to dock with the lunar module and pull it free of the now useless booster.
Apollo 12 Houston, the camera's cutting off about half the Intrepid now.
That's the best we can do. We're right next to it. Roger, 5 feet.
Apollo 12 moving into dock with the lunar module.
Gordon, silk. I think we just saw you grab it.
We're on the way in right now. We got a hard dock, Houston.
Dr. Gordon, I presume.
Better known to his friends as Tricky Dicky.
Hey, Red Baron, where's your scarf?
Well, I tell you, I think I forgot it during that boost phase. We ought to talk to you about all that good happening. That's a terrible way to break Al Bean into spaceflight, I'll tell you.
Roger.
Say, what time is the LOX blowdown on the S4B?
Stand by, 12. 12 Houston, Chris says he doesn't think you guys are the same age as when you got up this morning either.
He is absolutely correct. In fact, I wish you guys play us that DSE tape back tonight. All Al Bean kept saying was, there's power on the buses, there's power on the buses. And every light on the right-hand side was lit. I kept thinking, why is he saying that to me?
That's beautiful.
I was saying, Al, there's so many lights on, I can't read them all to you. See, he's totally recovered from lunch. See that?
Oh, it looks beautiful. That's a nice looking hat you're wearing, Al.
We got 3 up just alike in here.
We got something else for you, too.
I tell you, this command module is a good deal. Dick and I, being used to Gemini, just hand everything to Alan, say, hold it, and he's got 25 things in his hand.
The next burn would place Apollo 12 on a new path to the moon. Previous missions had followed a trajectory that would allow them to loop around the moon and, with no further burns, return to Earth. But Apollo 12, in order to land at the proper site with the proper lighting, would break out of the free return path. Should a failure occur, a burn of the service or lunar module engine would be needed to get them home.
7, 6, 5, flashing 99, 0, 2, 1, ignition, thrust, that ball valve. Okay, other valve now. 3, 4, 5, 6, very good.
Now they settle down to the routine of the outward flight.
We're trying all these things that we didn't have in Gemini, like toothpaste and shaving, and we're really having a ball up here.
Roger. All dressed up and no place to go.
Oh, we're going someplace. We can see it getting bigger and bigger all the time.
Then, on November 17th, they prepared for orbit around the moon.
Okay, Houston, we're maneuvering to the burn attitude.
Roger, we copied that 12.
We're beginning to go into darkness at this time.
Roger, 12.
Matter of fact, we're there.
Hello, 12, Houston, you're go for LOI.
Roger, Houston, go for LOI. Burn checklist is complete to -6 minutes, and we're holding a dead point.
LOI, Lunar Orbit Insertion, the burn of the spacecraft rocket engine that would place Apollo 12 into orbit around the moon. With this burn occurring behind the moon, there would be no communications with the spacecraft until it came over the lunar horizon. The command module, Yankee Clipper, the lunar module, Intrepid.
Apollo 12, Houston.
Hello, Houston. Yankee Clipper with Intrepid in tow has arrived on time. I guess like everybody else that just arrived, all three of us are plastered to the windows looking.
The next day, Pete Conrad and Alan Bean entered the lunar module, leaving Dick Gordon in the command module. Now the Intrepid and Yankee Clipper undocked and separated, preparatory to Intrepid's descent and landing on the moon.
Back off, Dick. There he goes.
Intrepid, Houston, looks good.
On the tube, Jerry.
Real good, Dick, real good.
Coming down at about 99 feet a second. You're looking good. Got 15% fuel. I'll reset my watch.
Intrepid, Houston, go for landing.
Over one. I just want LPD to the right a little. Roger, okay, Roger. 40 degrees, LPD, Pete. 40 That's degrees. So fantastic, I can't believe it. You're at 2,000 feet. How far? The boys on the ground do okay. 1,800 feet up, 39 degrees. You got 94 seconds of LPD time left. Okay, I want to move forward a little bit. 38. 38 degrees, 36 degrees. You're 1,200 feet, Pete. Okay, 1,000 feet coming down at 30. You're looking good. Got 14% fuel. Looks good out there, Dave. Looks good. 32 degrees. You're at 800 feet. 33 degrees. You're at 680 feet. 33 degrees. 600 feet. Antenna's okay. Thanks. 35 degrees. You're 530 feet. You're 530. 471. You're all right. 426. I got it. 400. You're in G66, Pete. Thanks. G66. Okay. Yeah, I gotta get over 330 feet, coming down at 4. Got 11%. Got loads of gas. 300 feet coming down at 5. Hey, look at that crater right where it's supposed to be. Hey, you're beautiful. 10%. 257 feet coming down at 5. 240 coming down at 5. Hey, you're really maneuvering around. Yeah. Come on down, Pete. Okay. 10% fuel. 200 feet coming down at 3. Need to come on down. Okay. 190 feet. Come on down. 180 feet. 9%. You're looking good. Gonna get some dust before long. 130 feet. 124 feet, Pete. 120 feet coming down at 6. You got 9%. 8%. You're looking okay. 96 feet coming down at 6. Slow down the descent rate. 80 feet coming down at 4. You're looking good. 70 feet. Looking real good. 63 feet. 60 feet coming down at 3. 50 feet coming down. Watch for the dust. Now, 46. Low level. 42 feet coming down at 3. Coming down at 2. Okay. Start the clock. 42 feet coming down at 2. 40 coming down at 2. Looking good. Watch the dust. 31, 32, 30 feet. Coming down at 2 feet. You got plenty of gas, dude. Hang in there. 30 seconds. 18 feet. Coming down at 2. He's got it made. Come on in there. 24 feet. Contact light.
Roger, copy contact.
Drop. Pro. Yeah, pro. Okay. Engine arm off. Okay. I'll cycle these valves. You got your engine command override off. Yep. Okie dokie. I'll cycle the main shutoff valve. Okay. Front seat closed. You get both regs closed, Dave. The regs are closed. Good landing. Hey, outstanding, man. Man, oh man, Houston, I'll tell you, I think we're in a place that's a lot dustier than Neil. The good thing we had a simulator, because that was an IFR landing.
Roger, Pete.
I was high, Al. I know it. Holy crap, it's beautiful out here. It sure is. It's something else. No, sir, about halfway between Site 4 and Site 3. I flew by the right side of the crater and then had to fly over to the left and land. We're in good shape.
Roger.
Please set your engine stop, Pete. Okay. You guys did outstanding targeting. I'll tell you, that thing was right down the middle. Beautiful.
Oh, we're glad to hear that, Pete.
As Conrad and Bean began preparations for their first trip of exploration, men on Earth began their attempts to fix their exact landing site. They were aided by Dick Gordon, orbiting in Yankee Clipper.
I have him tripping. Well done, Clipper.
Dick Gordon using the 28 power sextant for these sightings.
Roger, Clipper. Good eyeball. Well done.
A major goal of Apollo 12 had been accomplished. For before men can engage in meaningful lunar exploration, they must be able to select a precise site and get there. But now it was time to exit the Intrepid and begin the exploration and experiments. Conrad climbed out first.
And is that a pretty looking sight, that limb?
You're coming into the picture now, Pete.
Okay, got the old camera running. Okay. Down to the pad. Okay. Man, that may have been a small one for Neil, but that's a long one for me. I'm going to step off the pad, Mark. Ooh, that's soft. Hey, that's neat. I don't think him far. Let's try a little. Boy, that sun's bright. That's just like somebody shining a spotlight in your hand. I can walk pretty well now, but I gotta take it easy and watch what I'm doing. Oh, you'll never believe it. Guess what I see sitting on the side of the crater? The old Surveyor, huh? The old Surveyor, yes sir. Does that look neat? It can't be any further than 600 feet from here. How about that?
Now Al Bean left Intrepid to join Conrad on the surface of the moon.
Good shape. Yeah, pull the hatch closed here. Okay. Don't lock it. And if I'd have landed 20 feet behind where I landed, we'd have landed right smack in that crater.
Inadvertently, the television camera was pointed directly at the sun, causing the tube to burn out, the only unsuccessful aspect of the entire mission.
Pete, go ahead.
Okay. Yeah, we have the flag up. Like I said, I hope everybody down there is as proud of it as we are to put it up.
That's affirmative, Pete, and we're proud of what you're doing.
They prepared an experiments package to be left on the moon, an automated scientific station called ALSEP that would send information to Earth for a year, powered by a nuclear electric generator.
Okay. And we'll offload the ALSEP, I guess. No. We ought to be able to move out with this thing.
They moved to the site selected to set up the station.
Another one of those mounds over there. Where? Hey, you're right. What do you suppose they are? I don't know. It looks like a small volcano.
They put together the experiment station.
How far do you estimate we're from the lamp? 600 feet? 700 feet?
ALSEP, an acronym for Apollo Lunar Surface Experiments Package. Piece by piece, they assemble the station.
Okay. I got the solar wind deployed here.
The solar wind experiment, to measure atomic particles thrown off by the sun as they strike the moon. A device to measure the moon's tenuous atmosphere. A magnetometer to measure the lunar magnetic field, which would later be found to be 10 to 20 times stronger than many scientists had expected. A seismometer to measure physical properties of the crust and interior. And the data station to collect the experimental measurements and transmit them to Earth. With ALSEP deployed, Conrad and Bean began collecting geological samples.
Look out! There's a rock. Look at that. Son of a gun. I gotta have that.
They drove a core tube into the surface to collect soil from various depths.
Okay, I'm core tubing it right now. Kill me. Auger it a bit and pound it. But now it's full length.
We show you're 3 hours and 7 minutes into it, into the EVA. And we'd like you back to the LEM to start the closeout in 10 minutes. That's at 3 + 1 7.
Had to smoke to get back to that LEM. We're a long way. Yeah, Houston, we're approaching the ALSEP. Headed back to the LEM.
Pete and Al, we're picking up your heavy footprints going by the seismometer.
Okay, and then we ought to dust each other off. Man, we are filthy. Okay, coming up the ladder. Gosh, you're shaking the whole mill. Sorry about that.
Yankee Clipper, Houston. Hello, yes, Clipper here. Clipper, you were sort of the forgotten man for a little while. We're all eyes are on you now. We're with you.
As Dick Gordon circled the moon, Pete Conrad and Al Bean rested for their next expedition. Their total time on the lunar surface had been just under 4 hours. 12.5 hours later, they went out again.
Whoops, wrong step. Okay, Houston.
Roger. Copy, Pete.
Before they began their geological expedition to the surrounding craters and to Surveyor, they worked around the lunar module, getting ready the tools and containers they would need.
We're putting the parts bag on Pete right now, Houston.
Roger, we copy that.
And whatever happened since yesterday? I don't know. I think everybody learns a little. Okay.
As Bean readied the equipment, Conrad went out to the ALSEP station to check an instrument about which the Earth-based scientists had shown some concern.
I'll lope off to the ALSEP and check the size. I'll meet you at point 1 at head crater. Houston, Pete's on his way to the ALSEP.
After Conrad checked the ALSEP experiments, they began the geological traverse, during which they would cover about a mile and take samples from 6 craters.
You're going to get a big surprise when you look into this head crater, Al. It's a heck of a lot deeper than it looked, eh? There you go. That's a good rock. Hey, look at the pits in it, too. That's going to be a good rock, Houston. Okay, Houston, I'm coming up on Bench Crater right now. Well, there's some big fragments out here. What a fantastic sight. Al, look at the bottom of that crater. Here's some good rock samples right here. Come on. Well, we stop here and look at the chart a little bit more closely. Man, does that limb look small back there?
Pete, now we show you're 1,200 feet from the limb.
Okay. You know what I feel like, Al? You ever see those pictures of giraffes running in slow motion? That's exactly what I feel like. Got the decided feeling I'm going to sleep tonight.
Then they arrived at Surveyor, their target. While the Surveyor activities were a bonus, they were symbolic of the success of Apollo 12.
Yeah, we're just going to move to the area. Now look, you can see which way it came in. See the way the spear pits dug in over there? Dug up dirt, you're still sitting there. Okay, Houston, I'm jiggling it. The Surveyor is firmly planted here. That's no problem. Okay, Al, we're ready to start getting a TV camera. Okay. All right, you see that material disintegrate. Hey, that cuts easy. Okay, 2 more tubes on that TV camera, and that baby's ours. Done. There you go. In the bag. Yeah, I gotta zip it up. Good show. How about let me cut this scoop off? Sure. Didn't think you were gonna leave without a scoop, did you? Okay, let's head for Blackie Crater.
So they left Surveyor, and after a stop at the crater called Block, they were back at the lunar module, collecting the solar wind experiment, stowing the rock boxes.
It's really ridiculous. I got dust all over the rock box, and I'm trying to blow it off.
Bean re-entered the lunar module first. Conrad, using a transfer apparatus similar to a clothesline reel, sent the samples up to him. Then, Conrad, too, left the lunar surface.
Okay. Houston, guess you can mark me off the lunar surface?
Roger, we got that, Pete, at 3 hours and 50 minutes into the EVA.
Yeah, yep, for the ladder I come. I hope.
But there was no time to rest. The lunar module had to be prepared for liftoff from the moon and rendezvous with Yankee Clipper.
Looking good, Pete.
3, 2, 1, lift off. And away we go. Target is fired. Joy. We're on our way. And in 1 minute, y'all right 20 feet. Okay. Good jump. Everything looks good. Sure does.
So they rose to their rendezvous, and from Dick Gordon and Yankee Clipper,
Well, you sure look strange down there amongst all the sand dunes. All right. Looks good here. Okay. Looks good. Okay. Atta boy. Up a little bit. That's it. After. Okay, go free. Free. Very good. Go ahead, Doc. That's what I was supposed to be when I was free. Yes, sir. You're looking good. You're stable as a rock. Go ahead. Wait a minute. Just let me stabilize a little bit. Okay, it looks pretty stable to me. Thanks a lot.
now Conrad and Bean rejoined Dick Gordon in the command module, bringing with them the samples, experiments, and photographs to be returned to Earth. The next step, jettison the lunar module, then send it crashing into the moon to help calibrate the seismometer left on the surface. This instrument was designed to measure the intensity of meteor impacts, moonquakes, landslides, and similar phenomena.
Guidance and control officer reports that the two spacecraft have separated.
Apollo 12, Houston, the LEM is on its way down.
Roger, olarak, watch.
The men on Earth monitored the output of the seismometer, waiting for impact.
Countdown for LEM impact. 3, 2, 1, mark. LEM impact.
After 55 minutes, the reverberation still had not faded completely. Apollo 12 continued its orbits of the moon, gathering photography for scientific study, including the Fra Mauro area, the landing site for Apollo 13. And then it was time to head back to Earth.
Have fun.
The burn to send them home would take place behind the moon. On Earth, we waited for Apollo 12 once more.
Apollo 12, Houston.
Hello, Houston. Apollo 12 en route home.
When they were on the way home, Apollo 12 crew shared their feelings about the mission.
So the funny thing about moving around on the lunar surface, you put on this pressurized suit we wear, and you try to do it on Earth with even close to the weight you have on your back on the moon, and you get tired very rapidly from the walking. And you don't have to walk, over, let's say, 200 or 300 yards, and you're ready for a rest. But on the moon in the light gravity, with the same suit on and the same weight, your legs never seem to get tired. Now, I guess when you run up the side of a steep slope, you can do it, but just running around on level ground, you seem to assume some sort of a normal pace, and you're able to go for long distances without your legs getting tired. The suit doesn't always want to bend like you want to bend. For example, it bends pretty well at the knee, and it bends pretty well at the ankle, but it doesn't want to bend up near the side, the top of the side. So what happens is you tend to run with straight legs, land flat-footed, and then push off on your toes. And you think to yourself, well, I'm going to tire out my calves pretty soon because I'm not used to this sort of thing. But apparently the force it takes to push off on your toes on the moon is much less than you just have when you walk or run on Earth. so your legs just don't seem to tire. You can move around rather easily, don't you think, Pete? Yeah, I'd like to ask the doctors because I haven't any idea, but I'm sure that our heart rate stayed fairly low even when we were loping. I don't think we approached anywhere near the heart rates that we had in just our normal walkthroughs and practices in 1G back in Earth. And that ought to do it. Well, you end up like, I don't know if you can see this camera I've got on TV, the one that I'm taking pictures of the moon with, but they float around just like you've seen. But the funny part is, when you're not watching, they'll float off, and then you'll hunt for them. But the problem is, all your training all your life has been to hunt for them on top of things, like on top of the seat or on top of the floor or somewhere else. It's when you walk around the spacecraft hunting for them, when really they may be in plain view, just resting right on the underside of the seat, or maybe just up here near the top of the strut. And you have one whale of a time finding these objects. You look all around, and then somebody on the other side will say, look, it's right by your left ear. And it really becomes quite a lot of fun when one of these things gets lost and you spend a few minutes hunting around. They usually end up right in plain view, but you just don't look there from all these habits you built up over the years.
Hey, now we see Dick.
Hey, Donna, I understand you've changed your schedule around there quite a bit since we left last Friday. And we're very sorry about that, but that can't be helped either.
No problem.
We did our work, I understand, real early in the morning or very late at night down there. And we had to stay up very late the first night out, about a 20-hour day, to adjust our schedule to the activities around the moon. And we sure enjoyed it, and I hope that everybody there has enjoyed having us bring what we can to them.
Listen,
we were particularly disappointed that we weren't able to give you. Yeah, we were particularly disappointed that we weren't able to give you the lunar surface TV. It just didn't seem to work out, and I guess maybe the next flight, Apollo 13, will give you a chance to look at what's going on down there, because it's going to be a lot of fun.
Listen, everybody was absolutely delighted with the tremendous job you did.
We've got all our gear stowed in here, by the way. Why don't you show up some of the gear we got stowed? Surveyor bag particularly, because that's unusual, and we got it stowed in a pretty slick place. Well, I don't know whether they can see all of it, but we do. We got the rock boxes put to bed and all the Surveyor gear. I guess one of the big thrills, of course, for Al and I was to sit down next to the Surveyor, especially when we stepped outside and looked around back of the spacecraft. Yeah, I saw it sitting right there on the other side of the crater. I also gave myself quite a thrill. I think you'll appreciate it when you see the pictures and you see how close we landed to the crater, which I didn't notice at the time because it was behind me. But I didn't want to overfly too far, but I guess I parked it pretty close to the edge of the crater. And we were also very impressed that the tracking and everything put us right down the middle. Everybody at all certainly did their homework there. We didn't have to do anything but land her. And Dick surprised me, I think, by finding us, not only finding us in the sextant, but also finding the Surveyor and the LEM in the sextant. He also took some pictures through his sextant with 16mm camera of that on the next rev, and hopefully we'll have movies of the LEM and the Surveyor on the ground that are discernible in the movies. I don't know whether that'll work or not. We'll have to wait till we see the film.
Very good. We'll be looking for them.
We've enjoyed the trip. Everybody adapted to zero-G real well. We enjoyed whistling in and out of the LEM, and after having flown 8 days in Gemini, it's a real pleasure riding around in this thing, being able to move around and have all the good food and hot water and shave and all those good things we could do. We're kept the ship pretty spick and span, and we do have things all neatly stowed. I don't know if you can show them, Dick. Why don't you show them the Surveyor bag? Oh, okay. Can't see it. Well, with that, I think we'll sign off, and we'll see you in about 3 days.
Shortly before re-entry, the crew of Apollo 12 watched the Earth move to blot out the sun.
We're getting a spectacular view of the eclipse. We're using the sun filter from the GNN optics looking through it, and it's unbelievable.
Then Apollo 12 hit the atmosphere of Earth at 25,000 miles an hour. But the log of Apollo 12 does not end with splashdown. It only begins.
Man, have I got the grapefruit rock of all grapefruit rocks. I'm looking at a rock that has all crystals in it.
And on the moon, an experimental station called ALSAP sends back its data. Apollo 12 was a milestone in manned extraterrestrial exploration. It achieved its pinpoint landing, as close as possible to its selected target, marked by Surveyor. It set a pace and a pattern of scientific exploration that future missions will not only follow, but will go beyond.